students, welcome to our video class on sets. I am Renu and in this session we will explore the fascinating word of sets and understand its significance. Knowledge of sets is required for studying sequence, geometry, probability and many other streams. In our daily life too, we come across many collections and organizing these collections. For example, in our kitchen, a set of plates is kept separate from set of spoons. Here the word set comes. Yes, collecting similar things together. Similarly, in mathematics, we come across many collections, for example, of natural numbers, prime numbers, points, etc. And set is a concept that groups together objects with similar characteristics. Let's learn more about sets. In this session, we will learn about identification of sets and how to represent it. And we will also learn about empty set, singleton set, finite set, infinite set and equal sets. So, let us dive in. Starting with the definition. Well-defined collection of objects is called a set. Here the term well-defined is of paramount importance. Any collection will be called well-defined if we can certainly say whether a particular element belongs to this collection or not. For example, consider the collection of all vowels in English alphabet. It will be A, E, I, O, U. Now, if someone asks me whether letter E belongs to this collection or not, answer would be certainly yes. Now, if it is asked from you whether letter G belongs to this collection or not, you will certainly say no. One is certain in his answer because this collection is a well-defined collection. Now, let us consider collection of all months of a year beginning with the letter J. Now, if I put elements in this collection, I will write January, June, July. Or if I ask anyone else to do this job, he or she will definitely write same 3 months. Everyone will make the same collection without any exception because this collection is well defined. Now, on the contrary, if I ask you to make the collection of all beautiful girls in your class, someone may say Diksha belongs to this collection, while the other may opt for Akanksha or someone else. Now, this collection varies from person to person because it is not well defined, as each person has a different sense of beauty. Further, like beautiful, there are some other terms such as talented, renowned, rich, honest, good, old, young, etc., which are vague terms. Since criteria for determining these terms varies from person to person, so the collection involving these terms will not make set, as the collection is not well defined. Now, moving to notation of sets. Sets are usually denoted by capital letters like capital A, B or C, etc. Whereas, elements of sets are represented by small letters. Further, if we need to write X is an element of set A, then we will write it as X belongs to set A. This term is a Greek symbol epsilon, which stands for belongs to in mathematics. On the contrary, if we need to write y is not an element of set A, then we write y does not belongs to A. We will simply strike off the symbol epsilon to say does not belong to. Dear students, now we will learn how to represent the set. A set can be represented either by stating all its elements or by stating properties which are satisfied by the elements of the set and not by any other element. Based on these considerations, we have two methods of representing sets. First method is roster or tabular form, and second method is rule method or set builder form. Let us understand these forms with the help of some examples. If A is the set of all odd natural numbers less than 10, then set A will have the elements 1, 3, 5, 7, 9. In roster form, we list the elements separated by commas, closed within curly brackets. Now, consider set B as set of all prime numbers. Then, set B is having elements 2, 3, 5, 7 and so on. We will put 3 dots to show that the collection is not ending. Now, let us take another set C, which is the set of all letters of the word Google. This word is a 6 letters word having the letters G, O, O, G, L, E. In this collection, letters G and O are repeated twice, and we know that set is known by its distinct elements. Hence, we will write G and O only once in the set C. So, set C will have the letters G, O, L, E. Let us take one more example of set D, which contains 4 letters R, E, N, U. This set will be the same set if I write the elements as N, U, R, E. What point I am trying to make with this example is order of listing the elements makes no difference. So, we have learnt these 3 points in roster form. First, write all the elements of the set, separate them with commas, put them within curly brackets. Number 2, an element is written only once. Number 3, the order of listing the elements makes no difference. Dear students, now suppose someone asks me to write the set of all employees working in a company where we have near about 10,000 employees. Will it be possible for me to write down the name of every employee? It would be a very tedious job. So, we need to devise some method which is convenient and can be done easily. For that, we use the property possessed by all the elements of the set. Now, we will write down this as a set of all employees working in a particular company. It will serve our purpose because if the employee is working in that company, he will be included in the set, and if the employee is not working in that particular company, he or she will not be included. So, this method of writing set is known as set builder form or rule method. Let us take set A as the set of all natural numbers less than 50. Then set A will be written as A is a set containing x such that x is a natural number and x is less than 50. Here x represent the member of the set and this colon sign means such that. This set builder form is mainly useful when we are not able to write this set in tabular form. For example, let us take set B as the set of all real numbers lying between 3 and 5. Here we can see we cannot write this set by listing all the elements. So, we will write it as B is a set containing element x such that x is a real number and x lies between 3 and 5. Consider set A as a set containing all x such that x is a real number and square of x is minus 1. Now, we cannot find any real number whose square is minus 1. It means no element will be there in set A. This leads to the definition of an empty set. A set which does not contain any element is called empty set or null set or void set. It is usually denoted as empty set or phi. Further, if we are having set B as a set containing x such that x is a natural number and x lies between 1 and 2. Now again there is no natural number which is greater than 1 and less than 2. It will also be an empty set. If we consider this circle as the set B, then no element will lie in this circle as this is an empty set. Now, next topic which is lined up is singleton set. As evident from its name, a set is said to be singleton set if it contains only one element. For example, if we have set C containing x such that x is a natural number and x lies between 1 and 3. Now, there is only one natural number which is greater than 1 and less than 3. Yes, it is 2. Then C will be having single element 2 in it. Let us take up one more example. Here is set D which contain x such that x is an integer and x plus 4 is 0. We know minus 4 is the only integer which when added with 4 will give 0. So, set D will have minus 4 in it. If we consider this circle as set D, it will have single element 4 in it. So, it is a singleton set. Dear students, now we will get to know about finite and infinite sets. Finite sets, a set whose elements can be counted or in which process of counting its elements comes to an end. Or you can simply say a set having finite number of elements is called finite set. For example, A is the set of days in a week. A is clearly a finite set as it contains 7 elements. Let us take another set B, which contains all natural numbers less than 5. B will have the elements 1, 2, 3 and 4. Here set B contains 4 elements. So, this is a finite set. If we consider this circle as set, it will have 4 points to show elements 1, 2, 3 and 4. Coming to infinite sets, a set which is not finite is called an infinite set, or a set is said to be an infinite set if it has uncountable number of elements. For example, P is a set of even numbers. This set will contain all the even numbers starting from 2, 4, 6, 8 and so on. As this collection is going on and on, that is why it is an infinite set. If we take this circle as P, it will have infinite many elements in it. It's time to learn some standard notations for some special sets. Capital N stands for set of natural numbers, which you are already familiar with. Similarly, W and Z will represent the set of whole numbers and integers respectively. And Q stand for set of rational numbers and R for set of real numbers. Further, set C represent set of complex numbers, which you will learn about later on in the class 11 itself. Our next topic is equal sets. Two sets X and Y are said to be identical or equal, written as X is equal to Y, when they have exactly the same elements. To be more precise, X and Y are equal if every element of X is an element of Y, and conversely, every element of Y is also an element of X. From the picture on your screen, you can easily see elements of X are exactly the same elements as of Y. So, these sets X and Y are equal sets. Let us see one more example of two sets P and Q. Here, P and Q are equal sets as Q has a repeated element B, and we know that a set is known by its distinct elements. Now, we will learn about equivalent sets. Two finite sets A and B are equivalent if their cardinal numbers are same. That is, number of elements in A is equal to number of elements in set B. Thus, two finite sets are equivalent, written as A equivalent to B, if both have same number of elements. In this diagram on your screen, both the sets A and B have different elements, but the number of elements in both the set is exactly 3. So, both the sets are equivalent sets. So, let us have a quick review of what we have learned so far. In this session, we have learned well-defined collection of objects is called set. We have also learned in roster form we list the elements of the set, and in set builder form we state the property satisfied by the elements of the set and not by any other element. We have also come to know an empty set is a set with no element, and set containing one element is called singleton set. Similarly, a set with finite number of elements is called finite set, and set with infinite number of elements is called an infinite sets. And equal sets are the sets with exactly same elements, where equivalent sets are the set with same number of elements. It's time now to note down your assignment related to today's session. You will do this assignment after this session is over. With this, we have now come to end of today's session. Hope you enjoyed it. In the next session, we will be taking up 4 topics. Number 1, subsets. Number 2, subsets of a set of real numbers, especially intervals. Number 3, universal set. Number 4, Venn diagram. Thank you for joining this session. Keep exploring till we meet again.